All right, ladies and gentlemen, I want you to start on problem number 1, 7.6, day 2. We're finding the general solution like we did yesterday. So you need to separate, integrate, and solve for y. All right, ladies and gentlemen, thank you for working on that problem. All right, for those of you that were here yesterday, what is the first thing that we do? We separate. How are we going to separate? What do we do? All right. We want the y's on the left, x's on the right, so I'm dividing by y on both sides. That gives me 1 over y dy over dx equals x squared. I still need to do one more thing to separate. What is that? Multiply by the dx. And I have 1 over y dy equals x squared dx. All right. Now that we have separated, we can go ahead and integrate both sides. 1 over y. What is the antiderivative of 1 over y? Natural log. Now, I want to take a pause and talk about that. If you have the integral of 1 over x or 1 over y or 1 over u and you have a power of 1, then yes, that is the natural log. Okay? However, on the test, I still saw people trying to take something like 1 over x squared and writing that as the natural log as well. That is not correct. Just because you have 1 divided by something does not mean it's always natural log. If it is something to the power of 1, then most likely it is. However, if it has a higher power, then we rewrite it. Okay, guys? Then it's just the power rule. So please keep those in mind. All right, so yes, that is the natural log of the absolute value of y. What is the antiderivative of x squared? Plus c. Okay, we have integrated. Now we solve for y. How do we solve for y? We're going to exponentiate. We have a logarithm there. What is the base that we're going to use? Base what? E. So I'm going to exponentiate with base e on both sides to be able to cancel that natural log out. That leaves me with the absolute value of y equals e. And then in its power, 1/3 x cubed plus c. Yesterday, however, we saw an exponential property that helps us was something like this. What can we do when we see addition in our power? Split it how? I'm multiplying, so what are the two things I'm going to be multiplying? I've started it with the e. Times e to the c. But, like we discussed yesterday, if I do a constant to a constant, what is this? So I can just write it as another constant. So that is absolute value of y equals e to the 1/3 x cubed times a constant. But where does that constant go? Or where do we usually put it? In the front, right? So I have absolute value of y equals c times e to the 1/3 x cubed. All right? How do I get rid of the absolute value? Plus or minus. So let's write it. Y equals plus or minus constant e to the 1/3 x cubed. But as we discussed yesterday, if it is a plus or minus a constant, do we actually need the plus or minus? Not in our final answer. If you do, it's not wrong. You can leave them. But you can also just leave it as c e to the 1/3 x cubed. And that would be our answer. All right. Any questions on that one, especially from those of you that were not here yesterday? All right, then do problem number 2, please. Separate, integrate, solve for y. All right, I want to do something that I've seen in a number of different places and address it. So just as we saw up above, if we have addition, what does that split into? Okay, now, I saw a lot of people have 3e to the 2x times 3e to the 5y. The second one doesn't need a 3. Why is that? That's because I want us to look back up here. This is 3 times e to this power. What is this the power of? This is power of just e, not 3e. If we had had parentheses like this, then yes, you would have a 3e on both. But that is only the power on the e. So the 3 is just a constant. 3 times e to the 2x times e to the 5y. I'm going to let you go ahead and continue separating it and trying it out. One other thing I wanted to address. If I had e to the 2x and I asked you to take the derivative, what would we need to use to take the derivative of e to the 2x? Okay, if you're looking at it and say, hey, that needs the chain rule, then what do we use to integrate? What is the inverse of chain rule? Whenever, if you see something, you're like, hey, that's a chain rule. Oh, wait, no, I'm integrating. Oh, then I'd be doing u sub. So, when you integrate both sides, they actually both need a little bit of u sub. I want you to think about that. Give you another minute, and then we'll go over it. All right. I'm going to go ahead and separate. I'm dividing by my e to the 5y. Also going to multiply by my dx. I'm just going to do both at the same time. So that means I have 1 over e to the 5y dy equals 3e to the 2x dx. Are we good with that so far, guys? Okay, we are going to integrate both sides. Now, if some of you are thinking that this side needs a natural log, I'm sorry to tell you, but that is incorrect. This again goes back to what I was talking about up above. Just because I have 1 divided by something does not mean I automatically need a natural log. Instead, we would want to rewrite it. How would I rewrite that so I can integrate it? Negative 5y dy equals the integral. Actually, I'm going to bring that 3 outside. 3 times the integral of e to the 2x dx. Now, I said that we need some u substitution there, so let's go ahead and do it. Since I am going to be doing u sub on both, to make it less confusing, let's use 2 different letters. Let's use u on this side. U would be equal to negative 5y. What letter do you think would be good for this side? Well, I'll go with what we chose in second period, and that is v. So v equals 2x. But the process is the same regardless of what letter you use. What if I'm on the left? What is my du? dy, y, okay. dy would be equal to what? d over negative 5, correct? On the right side, what is my dv? To what? And so then what's my dx? All right, let's use that u substitution to help us out. So that means I'm going to have the integral of e to the u du over negative 5 equals 3 times the integral of e to the v times dv over 2. I'm going to go ahead and bring those dividing by 5 divided by 2 out to the front. So that should be negative 1/5 integral of e to the u du equals 3/2 integral of e to the v dv. Now I want you to notice how I am keeping my integral symbol. I'm keeping my du all the way through. Again, the notation is important. I show it to you away on our notes on purpose. You should be doing it the way I do it. Don't try to cut corners. Don't try to leave things out because you don't think it's important. We can now integrate. What is the antiderivative of e to the u or e to the v? So a left side, -1/5 times what? E to the u equals 3/2 times what? Plus what, guys? C. All right, let's go ahead and put our u's and v's back in. So that's going to be -1/5 e to the -5y equals 3/2 e to the 2x plus c. All right, we have separated, we have integrated, we used a little bit of u sub on that. Let's go ahead and solve. How would I go about solving this, guys? What would we do first? Actually, I'm going to let you go ahead and try that. Give you a minute. Try it. Solve for y. What would we do? Okay. Let's do this. What do we do first to both sides? Multiply by -5. Let's do that. So I'm going to multiply by -5. Let's see what that gives us. So that should be e to the -5y equals -15/2, right, guys? E to the 2x, and then -5 times c is just a constant. All right, how do we keep going? Natural log it. Is green now. So we're going to natural log both sides. So that's natural log of e to the -5y equals the natural log of all of this. So all of it should be inside of the natural log. So make sure you either have brackets or parentheses enclosing that entire side. All of that is inside your natural log. Okay, doing so cancels out this side and we're left with -5y. All right, and then what is the last thing that we need to do? Divide by what? -5. I'm going to go ahead and write this as y equals, I'm going to write it as -1/5 out in front. If you want to write it as the division, that is fine. Either way would be correct, but that should be our final answer. There we go. Okay. Once you have that, try problem 3. All right, ladies and gentlemen, how are we doing getting up to the point that I am at? So we have multiplied sine 4y on both sides, dx on both sides, got the separation. Integrating both sides requires that u substitution. So I have u equal to 4y. Eventually dy equal to du over 4. V is 3x. So dv equals 3 dx, and dx equals dv over 3. So eventually we'll have that 1/4 outside the sine of u, 1/3 out with the cosine of u. Now before we finish the problem, we're going to be integrating these. I want to show you something, because a lot of people on where we had to take the antiderivative of, I think, negative sine, if I remember correctly, we messed up the positive and negative. So I saw something on somebody's exam that I thought was pretty smart. Thought I'd share it with you guys. So starting with sine of x, we're going to be going down and taking the derivative. What is the derivative of sine? Cosine. What is the derivative of cosine? What is the derivative of negative sine? And what is the derivative of negative cosine? So that is how we go if we're taking the derivative. We go the opposite direction when we're taking the integral. So if I'm doing sine, I'm here, I want to go backwards. What is my antiderivative of sine? Negative sine. If I have cosine, what is the antiderivative of cosine? Do you see that? And that's something very simple that you can easily do to help you remind yourself. So that is going to be 1/4. The integral, we're taking the integral, 1/4 times negative cosine, so that's going to be negative 1/4 cosine of x, or cosine of u, equals 1/3 sine of v plus c. Let's go ahead and replace back in our u and our v. So that's 1/4 cosine of 4y equals 1/3 sine of 3x plus c. All right, how do we go about solving? So we have cosine of 4y equals negative 4/3 sine of 3x plus c. What's next? How do we get rid of cosine? We talked about this yesterday. Our inverse. 4y equals cosine inverse, or arc cosine of all of this stuff. And then, we're almost done, divide by 4. We have our answer, y equals 1/4 cosine inverse, or arc cosine of negative 4/3 sine of 3x plus c. All right. And that one's done.